joined us for another edition of Count on Us, Reasoning and Sense Making. Welcome, scholars. Today, we are going to explore word problems. You're going to have this awesome opportunity to become even a better math scholar. And we're going to work on fractions and decimals, multiplication, division, and number sense. I know, it's so exciting. Grab your pencil, take a deep breath, and get ready to do some math.
4, 3, 2, 1.
Welcome back to Count on Us, Reasoning and Problem Solving Grade 3. I'm Coach Young, and I am so excited that you are here with us today. It's been a while since we've been together, but we are now back on air supporting 3rd through 5th grade math learning on Monday afternoons and 6th through 8th grade math learning on Wednesday afternoons. Both shows will air from 5 o'clock to 5:30 p.m., so make sure you tune in. Our show will focus on specific grade level standards and problem-solving strategies to develop you into successful mathematicians. So let's get started. By the end of today's mini lesson, you will be able to say, I can represent a two-step word problem with models, pictures, and equations. Solving today's reasoning and problem-solving problem will be as easy as 1, 2, 3. Here are the steps we will follow as we solve today's problem. Step 1, read and understand the problem. Step 2, ask yourself, what do you know that will help you to solve the problem? And step 3, solve the problem by doing the math. For the first read, I will read the problem to you. Then we will discuss what the problem is about. At a craft sale, Laura sold 8 drawings for $6 each. She also sold a toy wagon. Laura was paid a total of $63 for those items. Laura's friend thinks the cost of the toy wagon was $49 because 63 minus 8 minus 6 equals 49. So let's think about what this problem is about. I imagine Laura selling her drawings at a craft sale for $6 each. I also imagine Laura selling a toy wagon. She received $63 in all for the drawings she sold and the toy wagon. Laura's friend believes that the cost of the toy wagon was $49. For the second read, I would like for you to read the problem along with me. At a craft sale, Laura sold 8 drawings for $6 each. She also sold a toy wagon. Laura was paid a total of $63 for those items. Laura's friend thinks the cost of the toy wagon was $49 because 63 minus 8 minus 6 equals 49. Now I want you to think about what the quantities and units are in the problem. Remember, quantities are the numbers and the units are what's being counted. In this problem, we see the number 8 represents the drawing sold. $6 represents the cost of each drawing. And $63 represents the total amount paid. For the third read, read the problem to yourself one more time. Think about what's missing from this problem. It is important that you understand what the problem is about, as well as understand the quantities and the units in the problem before rushing to try and answer the question. Now that we have done that, what questions can we ask ourselves about the problem? Here are a couple of questions I came up with. How much did Laura sell her wagon for? How much money did Laura make from the drawings she sold? This is a visual of the entire problem. This is the way your problem will look like virtually. Notice how this question has a part A, part B, and part C. If you ever see a part A, this means there are other parts to the problem that will need to be answered. Let's focus on solving part A first. Part A says, explain the error that Laura's friend made in finding the cost of the wagon. Enter your explanation in the space provided. Part A lets us know that Laura's friend made an error when finding the cost of the wagon. What error did Laura's friend make? Well, first let's think about what the numbers in Laura's friend's equation, 63 minus 8 minus 6, represent. We know that 63 represents the total dollar amount Laura was paid for the toy wagon and her drawings. 8 represents the total number of drawings Laura sold. And 6 represents the dollar amount of each drawing Laura sold. In Laura's friend equation, she subtracted the 8 and the 6 from 63 instead of finding the cost of the 8 drawings sold at $6 each and subtracting that cost from 63. So as you are working on your math problem online, remember that your screen will give you a work area where you can type in your response, including equations using the equation editor. This allows anybody looking at your work to clearly see your understanding of the problem. Now let's complete part B. Part B says, write an equation or equations to show all of the steps Laura's friend should use to find the cost of the wagon. Enter your equation or equations in the space provided. So what do we know so far? We know that Laura was paid a total of $63 for the 8 drawings sold at $6 each in a toy wagon. We need to find out how much money Laura made from the drawings she sold. Let's think about what steps we should take to find the cost of the wagon. We know that Laura sold 8 drawings and that the cost of each drawing was $6. The total cost of the 8 drawings can be found with the equation 8 times $6 equals $48. So Laura made $48 from her drawings. Since $63 is the total amount Laura was paid for her drawings and toy wagon, we can subtract $48 from $63 and it will give us the cost of the toy wagon. Don't forget, as you are working on your math problem online, remember to use your work area to type in your response and the equation editor to type in your equations. This allows anybody looking at your work to clearly see your understanding of the problem. Now let's complete part C. Part C says, what is the correct cost in dollars of the wagon? Enter your answer in the box. So what do we know so far? In part B, we found out how much Laura made from her paintings from the equation 8 times $6 equals $48. In part B, we also wrote an equation for how much Laura sold her wagon for. $63 minus $48 equals an unknown number. So what is the cost of the wagon? We know that 8 drawings sold at $6 each gave me a total of $48. Then we subtract how much we made from the drawings from the total amount of money Laura made at the craft sale, which gives us a difference of $15. Therefore, the cost of the wagon is $15. For part C, they wanted us to place the correct cost of the wagon in dollars. Make sure to do the exact thing they ask you to do for each question. So today, we read the problem for understanding, used what we knew, and solved a 2-step problem. What strategies did we use? We applied the 3-read strategy, we visualized the problem, and we drew a model to solve our problem. Now, you can represent a 2-step word problem with models, pictures, and equations. That's it for 3rd grade today. The next segment will be for our 4th grade scholars. See you next time.
Welcome back to another 4th grade edition of Count on Us. I am Coach Brenner. Today we are going to be looking at questions involving fractions and making sure that they are equal parts in the particular problem. Now, we know that throughout 4th grade we are working with division, multiplication, addition, subtraction. When we divide something, we're sharing something equally. But in terms of fractions, you start with the whole and then you're going to break things up evenly. And that's where you come up with your numerators and denominators depending on how many parts there are and how many parts certain people get. So in today's problem, we're going to be trying to see how many parts of something certain people get and then how many parts are left over from the whole. So remember, our denominator is how many parts something's broken up into. The numerator is how many parts a particular person in this instance receives. So stay tuned. We're going to have some slides coming up that shows the parts broken up so that we can really visually see.
Here's my graph I've been using to track my
share
gas
these parts
usage.
And how we can break them up.
Do you think
All right, 4th graders, so by the end of today's lesson, you'll be able to say, I can divide rectangular shapes into equal portions while considering how the size of the original whole affects the portion size. Now, before we start the actual problem, you guessed it, we're going to go into our 3-read protocol. This is going to help us solve the problem. Okay, our first read. What is this situation about?
Proportional relationship.
Our second read.
That's
what
one
are
way
the quantities
to check for
in this situation?
And
then our third read.
Make sure there's a
what mathematical questions can we ask about this situation? Now, the 3-read is really something, a strategy that we use to help us solve these problems and also just make it easier for us. See what parts we understand and what parts we might not still know that we need to use or what we have to use and so on. So the 3-read's great to use for our word problems.
1 gallon of gas.
All right, so let's look at the problem itself.
40 miles
Elizabeth and James went to the school picnic ready to eat lasagna. The teacher cut each pan of lasagna into 12 equal portions.
Remember, when
Elizabeth took 2 pieces and James took 4 pieces from the same square pan. All right. So here, this is our first read. So what's the situation about? Well, we know that there's a school picnic. They're eating lasagna. How many parts was the lasagna cut up into? 12 equal portions. And then how many pieces did James and Elizabeth get? They talk about that. And we know that it is in a square pan. All right, so what are the quantities in this situation? Elizabeth and James went to the school picnic ready to eat lasagna. The teachers cut each pan of lasagna into 12 equal portions. Elizabeth took 2 pieces and James took 4 pieces from the same
Now
square
divide
pan.
the number of
So what were the
miles by the
quantities
gallons of
in
gas
this particular
in the table.
situation? Well, there
What's
are
the value of
12
the second and
equal
third
portions.
ratios?
There are
We
2
know the
pieces
first ratio
for Elizabeth,
is 20
and
miles
there are
per
4
gallon.
pieces for James.
Go ahead.
All
I'll give you
right,
time
so
to
there's
try.
that delicious
On your
lasagna. All right, now, our third read, what mathematical questions can we ask
right.
about this
The
situation?
second ratio on the table,
So what
40
questions could we come
miles
up
divided by
with?
2 gallons
What
equals 20 miles per gallon.
fraction of the lasagna did
The
Elizabeth
third
take?
ratio,
Did James
60
take?
miles divided
Maybe
by
how much
3
lasagna
gallons of
was
gas
left? All
is
right, so
equivalent
these are some
to
possible
20 miles
questions
per
that
gallon.
we can ask or come up with
We have
while we're solving
equivalent
this problem.
ratios. So we can say the
All
graph
right, so now it's time
represents
to
a
solve the
proportional
problem itself. So
relationship.
here's our problem. The question
Remember
that we
at
have.
the
We have
beginning
Elizabeth
of the
and James
lesson,
went
I
to the
was at
school
the gas
picnic,
station,
ready to
and I
eat
pumped
lasagna.
5.5
The
gallons of
teachers
gas
cut
into
each
my
pan
gas
of
tank.
lasagna into 12 equal
Now I need
portions.
to figure out
Elizabeth
how
took
far can
2
I travel in
pieces
my car
and James
on
took 4
5.5
pieces from
gallons
the
of gas.
same square pan. All right, so we
Think
got
I'm
our
gonna use some
lasagna. So now the question is, what fraction
First,
of the
I need to
pan
figure
of
out the
lasagna
location of
did
5.5 miles
Elizabeth take?
on the x-axis.
So this is how we set it up. So we have our lasagna,
So
our
I
square
looked
pan.
at the graph,
We know that
and I found
Elizabeth
the location
had
of
2
5 gallons
pieces
of gas
and James had
and 6
4
gallons of
pieces.
gas.
If we
And
counted all of
halfway,
these
I
up, so
drew
I'm going to
a
grab my
vertical
pen here.
line.
And if
Let's
we
see
counted
what
all the
location
pieces,
on the
1,
y-axis
2, 3,
corresponds with
4,
5.5
5,
gallons of
6,
gas on
7,
the
8,
x-axis.
9, 10, 11, 12. There's 12
5.5,
pieces total. And how many
110.
pieces did Elizabeth take? We know that she
So
had
my
2.
car travels
So these were the
110
2
miles
that
on
Elizabeth
5.5
had.
gallons
Now,
of
once
gas.
we do that, we know
Let's
that
double check the
it's
2
2
ratios
out of
for
the 12,
proportionality.
right?
I'm going
So
to find a
2 would be my
quotient of 20
numerator,
divided by 1.
and 12 would now
and
be
see if
my
it's equivalent
denominator,
to
because 12 is the
110
total amount
divided
of
by
pieces.
5.5.
So if we're looking at that, we know that
They're
Elizabeth, when
Those
she did that,
ratios
she
are
ate,
equivalent.
how many pieces?
To
It
review
said there's
today's
12
lesson,
total
I
pieces, and
created
Elizabeth
a
had
proportional checklist.
2 pieces,
So let's
so
get
Elizabeth had
started.
2/12 of
Number
the
1.
lasagna.
Always check to see if the
All right,
graph
so
is
now
a
that we
straight
figured
line
out
and
how many
passes through
pieces
the origin
Elizabeth
0,
took,
0.
now let's talk about the
Number
portion
2.
that James took.
Identify
So it says
the
James took 4
coordinates for
pieces from the
each
same
point
square
on the
pan.
graph.
So what fraction did James take? So let's look. Just as before,
Number
we know
3.
that if we count with our
Divide
pen,
the y coordinate
there's
by
1,
the
2,
x
3,
coordinate
4, 5,
to check
6,
for
7,
equivalent
8,
ratios.
9, 10, 11, 12 parts. So we know that our 12 is our
That's it
denominator.
for 7th grade today.
Now, how many parts
The
did
next
James
segment
have?
will be for 8th
1,
grade students.
2,
See you next time.
3, 4. So he has 4 parts. Our 4 is going to go in our numerator. All right. So once we have that, we know that this is kind of like our notes, our scrap paper that we have here. Here, we know that once we do that, what was the fraction? Well, we already solved that. So there's 12 total pieces. James had 4 pieces. So James had 4/12 of the lasagna. All right. So we know that Elizabeth now had 2/12 and James had 4/12. What's another question that you think that we could actually solve here? Let me think. Here it is. What fraction of the lasagna was left in the pan? So here's the same picture we have. All right. So we know that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts overall. Now, how many parts did not have Elizabeth or James' name on it? 1, 2, 3, 4, 5, 6. So where's that 6 go in my fraction then? It's in our numerator. All right, so we have 6/12. Now, the fraction that was left in the pan, there's 12 total pieces. There are 6 pieces left, or half the lasagna. and you could have written this as 6/12 or 1/2 of the lasagna is left. Thank you guys for tuning in to another edition of Count on Us mini lessons with 4th grade. Today we looked at breaking up parts into equal pieces, how many parts somebody has, how many parts there are left. This is one of those real world examples as we're touching base on to show you where math is in everyday life. Another instance, I always come back to birthday parties or some type of gathering. If you have a cake, if you have if you have pizza, if you have brownies, something that you want to make sure that everybody gets an equal part, and that you also cut up enough of the pieces so that there's enough for everybody. Now, the important part here was also figuring out how much was left. Now, maybe another question that you could expand on is if they each got equal amount of what was left. If you know you had 6/12 left, how much would Elizabeth and James get if they split it up evenly? You know that one would get 3 and the other one would get 3 as well, so they would each get 3/12 to take if they were bringing it to lunch or having leftovers for dinner the next night. So these are just some other ways that you can kind of extend the problem, thinking about math and how it's involved in everyday life, and that's just where those real world problems come into play, just as we did with this one. So stay tuned. 5th grade is up next. Until I see you next time, remember, you can always count on us.
I am Coach Twitty, and today we are going to go over adding and subtracting fractions with unlike denominators. Are you ready? Grab your paper and pencil, and let's get ready to start. All right, so here's our problem today. We're just going to take a moment to read it, and then we'll talk about the work that we need to do. Leah incorrectly added the fractions 2/3, 1/2, and 5/12. She said that to add fractions with different denominators, you use the common denominator and add the numerators. Leah's work is shown, and here's Leah's work. She has 2/3 plus 1/2 plus 5/12, and she found a common denominator, added the numerators, and came to the conclusion that the answer, or the sum, was 8/12. So the questions ask, what is Leah's mistake? And then find the correct value of 2/3 plus 1/2 plus 5/12. Show your work or explain your answer. So there's a couple of things that we need to do. First, let's talk about what is Leah's mistake. So Leah said that you find a common denominator and then you add the numerators. Well, I do think that you are supposed to find a common denominator, but what was the step? She did not find equivalent fractions once she determined the least common denominator. Very nice job. So once you determine the least common denominator, you would need to find equivalent fractions for the other fractions that you're adding and then go and add the numerators. Oh, you all are so smart. So let's see how we can help Leah. All right, so the next step in the problem is to find the correct value. So that's what we're going to work on now. Hopefully you have your pencil and paper. Coach Twitty is going to use her white space right here as her pencil and paper, as well as some of the virtual manipulatives that you've been using at home. First, we are going to determine the least common denominator. Next, we will create equivalent fractions. Then we will add the numerators. And lastly, we will simplify if needed. All right, I'm so excited. Do you have the problem written down? Let's go. So the first thing we need to do is determine the least common denominator. Our denominators are 12, we have 3, and we have 2. So Miss Twitty always likes to start with the largest, and let's say 12. Can that be our least common denominator? It could. Let's start with 12. Let's see if 2 and 3 also have it in common, and it's the least. So I'm going to start looking on my multiplication chart in my 2's column, and I see a 12. Okay. Let's see in my 3's column if I find a 12. I do. Is there anything else that could be my least common denominator between 2, 3, and 12? I noticed these 2 6s, but if I had my 12s, there would not be a 6, so that won't work. All right, good job. I think my least common denominator for 12, 3, and 2 would be 12. Very nice job. So let's go back to our problem. And I believe we can check that one off. We have determined the least common denominator. We said that was 12, so let's give ourselves a check. That's 12. Next up, we need to create equivalent fractions. And for this, we are going to use one of the manipulatives that you've used in school. I'm sure you're familiar with it from Brainy Camp, our fraction strips. Now, just to make sure that we're all clear and we can remember, let's go ahead and write our fractions. So we have, the problem is 2/3 plus 1/12, 1/2, 2/3 plus 1/2 plus 5/12. And we've determined that our least common denominator is 12. So we'll be working with 12ths. All right, so let's get started with 2/3. I'm going to bring over 2/3. And then to find equivalent fractions using the 12ths, I'm going to see how many 12ths would equal 2/3. You can do this at home if you want to draw something on a piece of paper, or if you want to log on to your Brainy Camp in Clever and do this as well. All right, there we go. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8. So that is 8/12. And let's just change the color a little bit here. So I have 8/12 plus, okay, now I'm going to use my halves. That's my half. So maybe Miss Twitty should move this over a little bit. I'll write it down here. I have 8/12 plus, now I'm going to do the same thing with my 1/2. I wonder how many 12ths will fit there. 1, 2, 3, 4, 5, 6. Okay, so in the equivalent fraction to 1/2 is 6/12. And I don't need to do anything to my 5/12, but I'm going to put it there because I think it just might help me in solving my answer. So that's 1, 2, 3, 4, 5. Okay, now let's see. I know that my denominator is going to be 12ths because we determined that's our least common denominator. So how many 12ths do I have? 8/12 plus 6/12 plus 5/12. Now I'm just going to add the numerators. Well, 8 plus 6, well, I know 6 plus 6 is 12, plus 2 would be 14. And then 14 plus 5, well, I know 14 plus 6 would be 20, and 5 is one less than 6, so it would be 19. So I have 19/12. Wait, 19/12. 19/12. That is a fraction greater than 1. Oh my goodness, we talked about these in class. I know, it's so exciting when we find one. So the last step in doing our problem, remember, was to simplify if needed. So let's see if I take my whole, because we already said it was a fraction greater than 1 if the numerator is larger than the denominator. So if I add my 1 whole here, that would take away 12 twelfths, and that would give me 1 whole. I would simplify this to 1 whole, and that would have 1, 2, 3, 4, 5, 6, 7. 7 twelfths. So 19 twelfths is the same as or equivalent to 1 and 7 twelfths. How did you do? Did you come up with similar answers? Oh, I hope you did. I know you're really, really, really smart. Hey, it was really great seeing you today. In 5th grade, we worked on adding fractions with unlike denominators. We look forward to seeing you next week. And remember, you can always count on us.
Welcome back to Partnering with Parents. This is Coach Brenner. The past couple episodes, we've been going over how to help your child at home prepare for the state assessment, the MCAP. Today, we're actually going to talk about how you can use everyday household items within your house to help build that math understanding and understanding that math is real world stuff. There's a real world application, okay? So some of these things are just inside your house, inside your kitchen. There are questions that you can always ask your child when you go to the store. If you guys have enough money for certain things, if you're estimating, if you're rounding to try to get close to make sure that you're spending what you're supposed to. So partnering with parents today, we're going to be looking at some real world mathematical applications. So stay tuned. So this is an example of those real world applications. So we know that before school starts, we always have to shop for some type of school supplies. In this particular instance, Ms. Reese needs to get some school supplies for her class. Teachers have to fill their classroom up with supplies for students. The Parent Teacher Association is giving her some money. She's got $25. So we're going to try to help her buy what she can buy. So here are the costs of the school supplies here. We have pencils, a binder, crayons, ruler, paper, scissors, glue, pens. So what we are trying to do here is to figure out how she could spend the $25. This is just as if you're going to the grocery store and you have $25 and you're trying to get dinner for that particular night. Maybe you're going to end up buying some type of pasta, a meat that goes along with it, another side dish that goes along with it, some fruits or vegetables. So this is the same type of question that you might have. So what we know is that she has $25, okay? So this is what she does have. And we know that she can only spend up to $25. So some options might be if you have just the binder and crayons, because 20 plus 5 is 25. If you wanted to add up another 25, you could have your paper and glue, because 13 plus 12 is 25. Now maybe you want a couple different items here, more than just 2 items. You could buy some smaller items. You could buy that pencil, crayon, and a ruler, and that ends up being 4 plus 5 is 9, plus 11 is 20, so you'd have $5 left over. So maybe you would buy 2 sets of crayons. So these are some things that you can do with your child at home. You can pull up the grocery store list. You can pull up the Target list, something where you know that you're going to go shopping, and give them a total amount of what they can spend. Once you do that, that's when you can add those questions in. All right, I hope you guys enjoyed that example of the school shopping supply list. Now we've actually made our way into the kitchen. One of the things that you can do at home with your children is to actually cook with them, bake with them. This really connects math to the real world. One of the things that my son Tyler really enjoys is pancakes. So on the weekends, I try to make pancakes for him at least once. Now, what we do have here, we have some of the ingredients that we need. We also have some of the tools. Just like in math, you need tools, different strategies for you to help make things easier to get to that solution. The solution here would be making some pancakes. So we know we have our pancake batter. We're gonna need some eggs. It's important to know if it's 1, 2, 3, or 4, depending on how many servings you're making. So when you're looking at the pancake batter, you need to see how many servings you're making. Now, once you choose that, you have to measure out if it's 1 cup, 2 cups, 3 cups, 4 cups of that pancake mix. Then you add in your eggs. Now, once you get there, you need to make sure, how did I know that it was 1 cup? How did I know that it was 2 cups, 3 or 4 cups? Well, that's where we have our measuring cups. So we have our measuring cup. This is a larger one. You can see that there's pints, cups, and quarts on here as well. So these are some of those math tools. So when you're talking to your child, you're cooking in the kitchen, you're using some of these things, ask them questions. How many cups are in 1 quart? You can actually use some of these tools here to do that. You may have a smaller measuring cup. So here, you might put your water in or your milk. You might already have your mix in here with your eggs, and you need to add 3/4 of a cup of milk or water to create these eggs and mix it together in order to make the pancakes. And if you don't have something like that, you might have some smaller ones. So we have our 1/4 cup, our 1/3 cup, our 1/2 cup, and also our whole cup. So these are some things where you can ask your students, well, how many 1/4 of a cup can we use to make a whole cup? How many 1/3 of a cup, or how many 1/2 cups does it take to make 1 whole cup? These are some ways that we can really incorporate math into our households and really make connections with the real world in terms of mathematics. Now, depending on what your kids like, it might be pancakes, it might be cookies, it might be brownies. Really just try to incorporate some of that math talk, those math numbers into your everyday life when you're at home. Before we close out this Partnering with Parents episode, I wanted to give you guys just a fun little game that you guys can play with your children at home. And this is ages from 5 and up, because there's a couple different ways. Now, if you have a set of playing cards at home, we can do some addition, or where each kid gets, let's just say, 6 cards each. They flip a card over, and the first team or person to add them up, so 2 + 4 would be 6. Whoever said 6 first gets to keep the card. So it's just like regular war, except you're adding in that addition. Now, what you can also do is have subtraction war. All right, so they would just have to look at the larger number, and they would have to say 4 minus 2, if they wanted to switch it in their head, right? 4 minus 2 is 2, and they'd be able to get that as well. So that really helps out, especially those K through 2 students, so kindergarten, 1st, and 2nd graders. Now, 3rd, 4th, and 5th, we can kind of add on to this. So it's the same concept. Each child gets 6 cards or 8 cards or 10 cards, depending on how many you want to distribute. And they flip over a card. And this could be multiplication war. So you flip over that 4 and a 2, and a 4 times 2 is 8. So whoever says that quicker, they get to keep that. So this is just a quick little fluency game activity that I'm adding in here for the Partnering with Parents. If you have that deck of cards at home, it's just something that you guys can have fun with. It's just like playing any other type of game, like even Chutes and Ladders at home, where the students have to be able to add on if they're adding on 6 or adding on 5, depending on what they spin. But these are something that most households have. So if you have them, or you can create your own cards if you need to. And these are just a couple easy games. So addition war, where students flip over a card and they add it as quickly as possible, or subtraction war, or multiplication war. That's just another game that you guys can do, and you guys can see that math is everywhere, even in some of these games that we love and we know. All right, thanks for joining us again for this Partnering with Parents episode. We went over a bunch of stuff that you guys can do at home with your children to make math a reality when you're at home. Do some of those real world connections. We talked about, going back to school shopping, making sure if you have certain amount of funds, how you can distribute, how can you buy certain items. Those are some questions that you can ask your child. We went into the kitchen, right? We went into the kitchen, we made some pancakes. We talked about some of the tools that you can use when you're making food, such as pancakes, baking other things such as cookies or brownies. Just kind of bringing in some of those mathematical concepts, cups, quarts, the number of items, so those quantities. And then I added in a little game there at the end where we played addition, subtraction, and multiplication war. These are things that you can do with your children at home just to keep math going in their brain, them constantly thinking, even when they're not in their classroom or in school in front of a teacher, but just to get their mathematical understandings and concepts going. And it just shows that math is everywhere. Until next time, for Partnering with Parents, I'm Coach Brenner. Hope you guys have a great day.
4, 3, 2, 1.